function that can be written in the form f of x equals k times x to the a. Notice that k and a are constant numbers. They're not variables. So we're not talking about an exponential function here. We're talking about x to some power. That means a quadratic function is technically a power function. What we're going to deal with today is more like story problems with power functions, and so I think that's why they throw that in here. And we say that the constant a is the power, which I feel like you probably know that already. So if it was 2, we would say it's a power 2 function. But because we're talking about variation today, the number in front of that we call the constant of variation. And we did this last year in Algebra 2. We talked about something varying. This varies directly, or this varies inversely, or this varies jointly. And we're going to go over all those again today. But every time they give you a problem like that, the first step is you have to find that constant of variation. Sometimes that's called a constant of proportion. I usually say constant of variation. And that's why we're kind of throwing that in here, is because of those problems. Really try to shorten that, but there just wasn't a better way to do that. So part of your homework today, you're just going to determine, is it a power function? And if so, you're going to tell me the power, and you're going to give me the constant of variation. Doesn't seem like such a hard thing to do, but they like to throw in lots of different letters and variables in this to kind of throw you off. So I want to practice a few of these before we get into the variation stuff. Okay, if I go? This is the way your homework is written, so I use the same direction. It's up to you if you want to write them all down, but there is kind of some important directions here. It says determine if the function is a power function. Notice that they tell you that c, g, k, and pi are all constants, which means those are just represent some constant number. Obviously pi is a constant, but they throw in some other ones here. Just like we did this with polynomials. We said, is it a polynomial? And what do we care about? We care about the degree and the leading coefficient. Well, if it's a power function, I want you to tell me what power it is and what is the constant of variation or the constant of proportion. And so I just have 3 little examples here. In your homework tonight, I'm pretty sure I took these directly from that, but in the directions, if not, it's a little different. But they tell you which letters represent constants, and that's kind of the important part here. I started with the first one, which is just kind of very normal power function, nothing too tricky there. A function with respect to x equals negative 1/2 x to the 5th. Does that look like the power function form that I gave you? If I go back and say, I think my power function, how did I write that? F of x equals k times x to the a, where k and a are constants. That fits that, yes? So is it a power function? Yes. What would we say the power is? 5. It's just the exponent. What? A, what are you talking about? Yes. This is not from these directions, right? This is from the definition that I gave you on the page before. I just wrote this so you can see that it kind of matches up. Is there an A in actual number 1? There's no A, but there's a 5. Is 5 a constant? Do they need to tell you in the directions that 5 is a constant, or do you know 5 is a constant? What's the definition of a constant? It's not a variable, which means it doesn't change. It stays the same all the time, which means, AKA, it's a number. A definition of a constant is it's a number that doesn't change. A variable changes. You can plug different things in. So they don't need to tell you in the directions that 5 is a constant, because 5 is a constant by definition. It's a number. It's always 5.
So the x is a constant.
Is x a constant? No, x is the variable. How do I know? Because the only letters that are constants in this are C, G, K, and pi. That's not a C, a G, a K, or a pi, so that's my variable.
Yes.
So confused, Justin.
What do you want? I don't know what we're doing whatsoever. Like, I'm trying to figure it out.
Every problem has to have a variable in it. Most of the time, we use the variable as x, right? But in some of these problems, they're not going to use the variable as x, like on number 2. On number 2, there's no x in the problem. They throw in these other letters. And so they're doing that to see if you're paying attention of which letters were constants and which letter is not constant. For an equation, you have to have a variable in it. A variable changes. In this problem, I only have one variable, and it's x. And I should. It matches my definition. The other numbers should be numbers or constants. Negative 1/2 is a constant. 5 is a constant. So that fits the power function formula. Yes. So my power here is negative 5, and my constant of variation is negative 1/2. I don't know. It's not really negative 5. That was supposed to be my equal sign. Sorry. I stopped mid-question.
So it's this. If it only has one variable.
Yes.
Always.
Yes. But that's where the directions come into play. Because number 2, if you just take my word and I say it can only have one variable, and you don't read those directions of which variables also represent constants, you might say number 2 is not a power function, right? Because you might say, well, it has an M and a C, that can't be a power function.
But it's not stated correctly, so it's not.
So which, but C is stated in the directions that C is a constant.
So m is your variable.
So that means in this problem, M is my variable. Here's another trick of how you know M is the variable. In function notation, the variable is always written right there, like f of x, e of m. That means M is your variable. So that's another hint. But also it tells me up here that C is a constant. So although it says C squared, this is actually my constant of variation is actually C squared in this problem. E equals mc squared. You know what that stands for? I don't. Albert Einstein, right? That's his little equation. Mass and energy, I don't know.
So if it was like, GC squared.
If it was GC squared, then those would all just represent numbers in this problem, and it would not be a power function. So Brindley, before I answer your question, what is the power of this one? Well, where does the power come from? The exponent on your variable. And what's the variable in this problem? M. And so the power is actually just 1.
So why is your constant of variation C squared?
So if the power is equal to a constant, then it takes up the constant variation of those
Never mind.
Because C squared just represents, I need to look up what equals mc squared. I don't know what C stands for. It's like energy equals mass times acceleration squared or something. I don't really know what C stands for. But it just represents an equation. Here's an example. Area of a circle. Area equals pi r squared. That's the area of what? Oh, I just told you, a circle, right? Making sure. Make sure we're on the same page here. This is a power function. Any circle, you can find the area if you know the radius. Do you agree that r is your variable in this problem? Because the radius could be whatever you want. Your constant of variation is pi, because to make a circle, that's the definition of pi, that's where it comes from. You take the radius squared and you multiply it by that constant, which in this case happens to be pi. The constant can be anything depending on the problem. Does that make any sense at all? I feel like that we're making this much harder than it needs to be.
What if there's two variables?
There's not going to be, or it's not a power function. Like, if there's two variables, you say it's not a power function, and we're not dealing with it. That's not a power function. Yes. So what about number 3? Does number 3 fit the mold for a power function? Justin. Yes. What about this? Does this fit this mold of a number times a variable to another number power? Does this fit that mold? Right, where's the variable in this problem? Is the variable allowed to be the exponent in a power function? No, that's an exponential function. That's a whole different thing. So the answer here is this one is not a power function. I'm just going to say no. Whew. It's going to be a tough lesson. That was our first examples. Yes, Justin. Because this constant in this case happens to be c squared. So whatever c was in the problem, you actually have to plug it in and square it. So the constant is just whatever's the constant. If it's a power with it, that's why I put that one on here, because I knew it would be really tricky, because lots of people want to say the power is 2 in that problem. The power is whatever's on the variable. It doesn't matter what's happening with the constant. Okay. Let's move on. Monomial function. A monomial function, I feel like these are very repetitive, but a monomial function and a power function can pretty much almost be the same thing, and we'll see if we can figure out the difference between these two as you write this. They give you 2 here because one is a monomial function could just be a constant function. F of x equals k. Doesn't have to have any x at all on it. Most of the time when we think of monomial functions, we think of something like this. F of x equals k times x to the n. That looks kind of like my power function, only I changed from x to the a to x to the n. And notice that k is still a constant, which sometimes is represented by a letter, but they tell you that it's a constant. But n is restricted here to be a positive integer. If you go back and you look at what we wrote on a power function, we said a power function, k and a just had to be constants. We didn't restrict it, which means you could have negative exponents. You could have fractions, like there was no restriction there. But to be a monomial, you can only have a positive integer there. Okay, so you can't have a negative exponent. It's just nice stuff. It's kind of like a polynomial, but it's just no adding and subtracting is what a monomial is. Monomial means 1, polynomial means many. So I feel like this one's going to go better than the last one. We're also going to have some problems, and you're going to decide, is it a monomial or not? They don't usually throw in as many letters, so I feel like we'll be okay. So let's look at it and see if we agree. Positive integer. And again, just like polynomials, it's asking you for the degree and the leading coefficient. Pretty soon, I think the next section in this, I'll just show you. Let me see. The next section in this chapter, we're going to be graphing polynomial functions and solving and all this fun stuff. And so it's really important about the leading coefficient. Is number 4 a power function? It has the constant in front, which happened would be -6, and it has a letter to a power. It's a power function. Is it also a monomial function? Yes. This is a nice constant number here. This is a positive integer. And so yes, it is a monomial. And just like we did on that worksheet over 2-1, you should be able to tell me hopefully the degree and the leading coefficient without much trouble here. What's the degree of this? 7, and the leading coefficient? -6. Okay, we're good with that. Maybe. Justin. What would the power be? What's the power on that variable? 7. And the constant of variation would be -6. So the power is like the degree. The only difference is you can't have negative exponents on a monomial. And just like the last one here, I kind of gave you a very similar problem here. Is this a monomial? You can't have x in the exponent. You have to have x to a power, x to a number. So this one is not a monomial. If you still have a lot of questions on that, I would highly recommend looking at the beginning of this section 2.2 in your book and looking at the examples and the words that they explain it thereby. Because that's why you have a book and you pay good money for it. I want to get to the variation stuff, and hopefully, maybe, I don't know. We did this last year. People liked it last year, at least my students. I remember people saying they felt like it was easy. So we'll see if we feel the same way today.
Days are wrong.
Yeah, I don't know. Kind of too many days off, I think, is what's happened. There are different types of variation, and the way that these are written in your book, you got to recognize when it says directly proportional or proportional, that tells you to set it up with this format and solve for a constant of proportionality. Again, I threw in here, remember that K stands for that constant of proportionality. And anytime you see something, this is what you're going to see in your homework, only it's not going to be as directly as y varies directly to x. They might say the radius varies directly to the circumference of a circle or something like that. But whenever you see these words, varies directly, or you see the words directly proportional, what that tells you is this is the type of equation that you're going to set up. You're going to set y equals constant times x, and then you can solve for k when we do that. And we're going to go through a few examples here with actual word problems here, not just basic. We also learned that there's other types of proportion. Directly proportional is what we see the most, but we also have inverse variation. And again, I put in quotations here what you're going to see when you see a problem, and you're kind of looking for those specific words. If you see the words varies inversely, this varies inversely to this, or you see the words y is inversely proportional to x, well, inverse means like the reciprocal, so instead of multiplying by your constant, you're going to take your constant divided by x. You remember doing this last year, or no memories? And in Algebra 2, we were very straightforward, like pretty much all your homework just used letters like x, y, and z. We're going to kind of go the next level in pre-calculus, and we're going to throw in more application problems. And there's one more type of variation that shows up sometimes, and that's joint variation. And joint variation is just where there's more letters involved. And so it's still multiplied, so you're still taking that constant times your other things. But if it says varies jointly or is jointly proportional, that means there's 3 variables involved in that problem. I feel like most of the ones on your homework today are directly proportional, but I wanted to give you all these just in case. And then the rest of our notes are some story problems, and so I thought I would save us some time, and I wanted you to write out this first part of the notes because I feel like you learn better when you write it. But for the rest of it, I did print out the next 3 examples so that you don't have to write all these story prompts out. And so if you want to label this at the top, choo-choo, kind of put it with your notes. And instead of just being very vague and saying y varies directly as x, when y equals this, x equals this, find blah, 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 that's what we did in algebra 2. We're going to look at these problems like this on your homework today, which are more application of direct, inverse, and joint variation. And so let's kind of see how we do, so we can work through some of these. Am I done writing this? And so this is what I just passed out to you. It says, write the statement as a power function. So that means all of these you should be able to write in that format with a constant and a variable to a power. Use k for the constant of variation if one is not given. So some of these problems, they're going to give you the constant, especially if it's like a geometry formula that we can use. But if they don't give you one, you're supposed to just use k. All right? And so notice we're not even solving this. We're just writing the equation. So it says, the area A of an equilateral triangle varies directly as the square of the length S of its sides. You should be looking for what letters you have in the problem, what you can use as your problem. And also, notice right here, varies directly. Varies directly, if you use my little generic one, we could say that's our equation, y equals k times x, right? Everyone with me on why I got that? Because it says varies directly. But let's use what letters they give us. What is varying directly? Not y. What's varying directly? What's before varies directly in this problem? The area A of an equilateral triangle. So what do you think I'm going to put instead of y? A. They're even telling me what letter. The area of an equilateral triangle varies directly as the square of the length s of its sides. So varies directly, I'm going to keep my k in there. How would I write what's on the other side of varies directly? The square of the length s of its sides. Yeah, the sides, the square of the side s. So side square.
So your constant of variation is k.
Because they don't tell us what the constant is or how to find the...
Variables s and 2 power.
Yeah, so this is definitely a power function. K is your constant, exactly like you said, Logan. It would be a power of 2. S would be your variable. So we just got to be okay with having multiple letters in our problem, even though they all don't represent variables. We're not doing any more with this on most of our homework because we're just practicing writing these. If they gave us some information, we could solve for K, and we're going to look at one of those in a minute. But part of your homework today is just practicing writing those equations. So let's see how we feel about the next one. The speed p of a free-falling object that has been dropped from rest varies as the square root of the distance traveled d with a constant of variation k equals the square root of 2g. Ooh, that's a lot of stuff, right? I like to look through and find my letters, and it's kind of nice because usually in these problems they tell you what to use for letters. What letters do I have to deal with in this problem? P, which represents the speed of some free-falling object. And what else? D. It's a little more involved than just D, right? It says as the square root of the distance, so I have to keep that in mind. With a constant of variation, I think A is just the word A in this problem. With a constant of variation of, and they tell us what to use for K. I do want to point out this when I picked this one, because it doesn't say varies directly in this one, right? It just says varies. So maybe we should go back and add when we wrote our notes out for varies directly. If it just says varies, that's another way to say varies directly or is directly proportional. Let me go back a second just to throw that in there. Sometimes it just says varies. And since direct variation is the one we use the most, that's why sometimes they just say it varies. And so that still means you're going to use that direct variation. So if you want, I'll start with this. Y equals kx. And then you just got to fill in for all those values there. So normally we say y varies directly or varies as x. What's my y in this problem? Yeah, the speed varies. It's always what comes first. And am I going to use k for my constant of proportionality on this one? Constant variation. Yeah, they tell me what my constant is. So instead of using k, the constant is going to be the square root of 2 times g. I'm guessing g has to do with gravity, but I'm just kind of throwing that out there. And gravity is always a constant, so that's why it's constant. And am I just going to put d here? Yeah, so be really careful. It's nice to go through and pull those letters out, but make sure you read the words around it. It's not just d. It varies as the square root of the distance d. So how would I write that? Square root, right? Not d squared. So I think we should take the square root of d. So you could write it like this. I bet the back of the book, since all that's in a square root, I bet the back of the book would write it like this. We could just put it all under there, because that's the same as that. Would I mark that wrong? No, I wouldn't. But just because it's all under a square root, you could put it all under a square root. That's kind of a crazy one. What would our power be on this one? What was the power on that variable? 1/2, because a square root is the same as a 1/2 power. They're not asking you to say that, but it does still meet the power function rules. This would be the 1/2 power. This whole thing would be our constant, the square root of 2g. So just try to think about those as you're doing them. And I'm sure there's some that are odd. Try to get it yourself before you just copy out the back of the book, but it's always nice to look in the back of the book to see if it matches up, and if it doesn't, see where you can go from there. So let's do one where we actually can solve it and find a value here. So there's my last one. And this is the real reason I'm putting these out. So look how long this is. It says the power P in watts produced by a windmill is proportional to the cube of the wind speed V in miles per hour. Directly, yeah, but that's another way. So like, just like they can leave out varies directly, they can leave out directly proportional, they can leave out that word directly, and it still means that same way. And like I said, I feel like almost all of your homework is all directly proportional today. If I stopped right here at this first sentence, that's exactly what we just did. We should be able to write an equation, given that first sentence, relating the power to the wind speed. And then after this, they give us a bunch of information, which means we're actually going to be able to solve and get an answer here. And so I'll read the rest of it, and then we'll kind of work our way through it. It says, if a wind of 10 miles per hour generates 15 watts of power, how much power is generated by winds of 20, 40, and 80 miles per hour? Which means we have to find that constant of variation. We're not going to be able to just leave it as k in this problem. So let's just stop right here first. Let's do the first sentence, and let's write our power function. The power P produced by a windmill is proportional to the cube of the wind speed V. I can start with my y equals kx again, if you like. Sometimes you might just go ahead and start with the letters that are given, because you'll kind of get used to this. What's proportional? What's going to be my y value? P, the power produced by a windmill is proportional. Do they tell me what k is? No, so I just have to leave k. And what's it proportional to? The cube of the wind speed v. So how would I write the cube of v? Is it the cube root? Or would it be cubed? I know the answer. I'm asking, see if anybody feels confident. I think we wrote, here I'm going to go back for a second. On this one, when it said as the square of the length of S, we wrote it as side squared, right? That didn't mean the square root. When it actually said square root, that meant square root. So using that, what do you think? Do you think that it's going to be v cubed, or you think it's going to be the cube root of v? The cube of v is v cubed. If it just said write your equation, that would be what you're doing. But it says actually solve for this. So here's my little steps here. Step 1, you're going to write your equation, which we've been doing. If you're actually solving for something, step 2 is you have to find what that constant is first. So now you have to solve for k. And you might say, well, how can I solve for k when there's all letters in my problem? They're going to give you enough information, which means they should give you a p and a v number that you could plug in, and you could solve for k. And look at that next sentence. If a wind of 10 miles per hour generates 15 watts of power, are they giving me two numbers there that go together? A wind of 10 miles per hour, where does that go? Is that my P or is that my V? Okay, that's the wind speed, so this is like your V. Generates 15 watts of power, that's your P. You can use that given information and solve for K. So I could say 15 equals K times 10 cubed. And you can actually tell me what is the constant for this specific windmill. We did this a lot with exponential stuff last year. Remember with like the whole half-life, you remember that, those awful problems? No idea what I'm talking about? 1,000. 10 squared is 100, 10 cubed is 1,000. So I'm going to divide by 1,000. And I'm going to get that k equals, if I divide that by 5, that would be 200, is that right? Or 0.015, if I would do that. You know me and my decimals. Yeah, it's the same thing, whichever one you want to use. Once you know k, you can answer anything that they ask you. And so, once you know k, then you can answer the problem. Because once you know k, you can actually write a specific equation. We can say, not only does p equal k times v cubed, we can say for this specific problem, we know that p equals 0.015 times the wind speed cubed. So look what's left in this problem. How much power is generated by winds of 20, 40, and 80 miles per hour? How would you do that? Yeah, it's just on your calculator now. You're just going to plug in those different values. And so for 20 miles per hour, I'm just going to plug that in. I'm going to say P equals 0.015 times 20 cubed. And I'm just going to type in my calculator. So the end of these problems are just a calculator problem. It's just getting the equation, solving for k, and then you just do what it asks. Cubed. I got 120 watts of power. And you're just going to plug in the other ones here. 40 and 80. So for 40 miles per hour, that's just 0.015 times 40 cubed. You can check me here, but I got 960 watts of power. And for 80 miles per hour, that would be 0.015 times 80 cubed. And that would be 7,680 watts of power. That's a lot. 80 miles per hour. The reason that we use K is because for every windmill, although every windmill, the power is the constant times the wind speed cubed, that constant's going to change for every windmill because every windmill might have a different way, a different amount of power that it's producing. So that's why you got to solve for k first. All right? Okay. So here's your homework. 3 through 24 multiples of 3. The beginning problems are, is it a power function? State the constant, state the power. So definitely get started on that. You have about, I don't know, 6-ish minutes, 7 minutes. So that way if you get stuck on those first couple that we can talk about them. And then it gets into the writing the equations, and then the last few problems are the story problems. We'll definitely talk about a few of these tomorrow, but try them. Don't just leave them all blank because we're not going to be doing this whole assignment in class tomorrow.